Hello dear students, welcome back to NEET World. So in this session we will be starting our discussion on Amines chapter, okay, and this session is useful if you are preparing for NEET, JEE or EAPCET, okay. So if you are preparing for any of these exams, this session is highly helpful, okay, right, let me set everything here, yeah. So if you are preparing for any of these exams, it will be highly helpful, right. So in the last session, if you have seen the videos, I have covered aldehydes, ketones, carboxylic acids, okay, and before that we have did alcohols, phenols, ethers, and before that we have discussed about haloalkanes, okay. So I hope you have watched all these chapters, whatever the sessions I have taken in online through this YouTube live sessions. I hope you are using them for making your preparation more effective, okay, right. So again guys, at least try to watch the last sessions of each of this chapter, because at the end of that session, at the end of the chapters, I will be taking some important PYQs from each chapter and I will be explaining them, I will be solving them in these sessions, okay. Please watch them so that will be highly helpful for your preparation, okay. Let's begin our discussion on amines, okay. Right here, what do we mean by amines? See, we know ammonia, right, like ammonia means NH3, right. So now if you replace one hydrogen of this ammonia by one R group, okay, now what I am doing, one alkyl group I am adding and I am removing one hydrogen from this ammonia. So we are going to get something like RNH2. So alkyl amine. What is this? Alkyl amine. So if on this nitrogen only one alkyl group is present, you should call it as a primary amine. What is it? Primary amine. Okay. Now here I am replacing two hydrogens with alkyl groups. Now what happens? On nitrogen we have two alkyl groups like this. Okay, one hydrogen is there. So you should call this as a secondary amine. Okay, now I am replacing all the three hydrogen, so that I am going to get a trialkyl amine like this. Okay, so you can call this as a tertiary amine. Okay, now what I am doing is I am adding one more fourth alkyl group like this. R. These are three alkyl groups, and here we have a lone pairs now. So to that I am adding a one carbon chain, like carbocation I am adding, so that it becomes a like a methyl or some alkyl group I am adding. Now what happens, four alkyl groups are there now, so you can call it as a quaternary ammonium. Okay, quaternary ammonium ion. So primary, secondary, tertiary, quaternary. Okay, these are the things to be remembered here. Okay, right. I hope you can easily identify now what do we mean by secondary, tertiary and primary amines. Okay, now just identify here what type of amines we have here, the given compound. Yes, so I am numbering them as A, B, C, D. So identify what type of amines here I have indicated. Tell me. So those who are watching through live session, please answer me. What will be the classification here? What type of nitrogen it is, or whether it is primary, secondary, tertiary amine, or what exactly it is. So tell me. Now I just wanted to add few more things here. NH. Yes. Tell me what it can be. So this is a amine. Okay, amine means that nitrogen should be having an sp3 hybridization. See, in the ammonia, what is the hybridization of nitrogen here? We have 3 sigma bonds with the hydrogen and one lone pair right now. So it is an sp3 carbon. What is it? It's a sp3 nitrogen atom. Since sp3 nitrogen atom having 3 bonds like this, you are going to get sp3 means it should be actually tetrahedral, but there is no fourth bond, there is only lone pair electrons. So this make it to be a pyramidal geometry. What is it? It's a pyramidal geometry, pyramidal structure you can say. Okay, electronic geometry will be tetrahedral, okay, but when it comes to molecular geometry, molecular structure, it will be pyramidal. Okay, right. So now here amines are also having this structure similar to this ammonia. Okay, remember this. Now identify what is the primary, secondary, tertiary amine here. So A is having 3 sigma bonds and 1 lone pair. No? So sp3 nitrogen. So it means it's an amine, ammonia like amine. How many alkyl groups are there? 1, 2, 3. Alkyl groups are nothing but to this nitrogen, just count number of carbons attached here. This side one carbon, it means alkyl chain. Here one carbon is a alkyl chain. This is also a carbon. So 3 carbons attached on the nitrogen means it should be a tertiary nitrogen. Okay, identify primary, secondary, tertiary is one of the important factor, because there are some reactions called like carbyl amine test I am saying. So it is specifically given by primary amines. It means you need to identify first of all which is primary, which is secondary, like that, right now. Then only you can able to do. Okay, now tell me here, what about this nitrogen? See, no need of worrying about what are the alkyl groups present here, but it should be looked at the nitrogen atom. How many alkyl groups attached to the nitrogen atom of amine? That decides what type of ammonia amine it is. See, only one alkyl group, one carbon is attached to the nitrogen atom here. It is like NH2. So it can be a primary now. And now tell me here 2 alkyl groups are there this side and this side. So it should be a secondary. Now what about this? Only one alkyl group is attached. It is a primary. Now what about this nitrogen? A, B, C, D, E. So what about this nitrogen? So this nitrogen cannot be considered to be amine. Why it cannot be considered to be amine? See, this is not having sp3 hybridization. It is sp2 hybridized. See, so to this nitrogen, we have a carbon and nitrogen with a pi bond. Okay, but in all these cases we have only sigma bonds, but here we have a pi bond now. So it should be called as an imine. What is it? It's an imine. Okay, these are amines, these are imines. So in imine, nitrogen hybridization is sp2. What is the hybridization? sp2, because see, one sigma bond, another sigma bond and one lone pair. Okay, so 2 sigma bonds and 1 lone pair, that means sp2 hybridization. Okay, so this is how you need to identify which is amine, which is imine, and types of amines here, primary, secondary, tertiary. I hope this basic discussion is clear, right? Let's move forward with a few more things here, right? So classification is done. See, for your understanding, this is a bookish examples, like whatever the things mentioned in the book I have considered here. So just to see here, cyclohexyl amine is a primary amine, tertiary butyl amine, it's also a primary amine. Yeah, so in the exam we can expect a question like giving their normal names, like common names or IUPAC name. They may ask us identify the secondary amine, tertiary amine from the below 4 names. First one is cyclohexyl amine, second one is tertiary butyl amine, like that, or aniline. Like this they will give you 4 names and you need to identify. So you just write their structures and you can get them. Okay, so for example here cyclohexyl amine means like this, tertiary butyl amine means like this. Okay, so here N-ethyl aniline. N-ethyl aniline means whenever there is a capital N, so it indicates that alkyl group is present on that nitrogen atom. Okay, like N dialkyl amine, it means what? On nitrogen only 2 alkyl groups are there. It means it's a secondary amine, like that. Okay, hope the discussion is clear, right? So now how can we write IUPAC nomenclature for them? Okay, so now whenever you are writing common name should be alkyl amine. Okay, it should be alkyl amine. So for example, if it is methyl, NH2 is there, so you should say methyl amine is a common name. If it is ethyl amine should be the common name. See, here ethyl group is there, so ethyl amine is a common name. When it comes to IUPAC nomenclature, so the name should be like alkane amine. What is the generalized name? Alkane amine. So here A and E, 2 ovals are there, so remove E, alkane amine. Okay, so here it is ethyl now, so ethanamine. What is the name, IUPAC name? Ethanamine. So here you can see 3 alkyl groups, 3 carbons are there, so it should be called as propyl amine as a common name, and it's a straight chain, so N-propyl amine is a common name. When it comes to IUPAC name, it should be propanamine, so it should be propanamine. Okay, and here if you see, just count the give the numbering for them. So 1, 2, 3. See, we can give the common name as isopropyl amine. Isopropyl amine is a common name, but IUPAC name at second position NH2 group is there now. So so you can say propane 2 amine. At second position we have amine group now. So propane to amine. So propane to amine. Then next here you can see this side of nitrogen, one side is ethyl group, another side is methyl group. So you should write the name as alphabetical order: ethyl, methyl, amine. So ethyl, methyl, amine. What is this? Ethyl, methyl, amine is a common name. When it comes to IUPAC name, identify the longest chain from these substituents. Here only one carbon, here it is two carbons. So we know two carbons, like more the number of carbon chain, that should be considered to be parent chain right now. So now this substituent, this small group should be considered as a substituent. So you can say it as a nitrogen atom only we have small group now. So N-methyl ethanamine. So what is this? N-methyl ethanamine. See, N-methyl ethanamine is a common name, IUPAC name. So this is how you need to write the name. Okay, right. Is this clear? Whatever we are discussing, is this clear or not? Guys, if the discussion is clear, please click on the like button. Yes. Next, let's move forward. Yeah. So if you see on nitrogen, we have three methyl groups, 1, 2, 3. So what will be the name of this compound? So trimethylamine, 1, 2, 3. So trimethylamine is a common name. When it comes to IUPAC name, NN, like NN, like on nitrogen only two methyls are there, NN dimethyl methanamine. So NN dimethyl methanamine is a IUPAC name. So like that I have given few more examples, you just follow them. Right. Let's move forward with their preparation methods. See, there are different ways to prepare this amine. Let's go one by one. Okay. So first one is from alkyl halides. So from where? First one is from alkyl halides. Okay. This method is called Hoffman's ammonolysis. Okay, Hoffman's ammonolysis. First one is from alkyl halides. This method is called Hoffman's ammonolysis. And these two methods are very, very important. Even second method, Gabriel's phthalimide synthesis, is one of the very, very important method to be remembered here. Okay, I will tell you in a simple way possible, and you can understand them in a easier manner. See, first of all, let's understand what Hoffman's ammonolysis means. See, you need to take alkyl halides, okay, and you just treat this with ammonia, like NH3. Now what happens? We know halide ion comes out, okay, as a X minus, creating positive charge on the carbon. So there this ammonia will attack. So it means you are going to get RNH2 type of product. Okay, right. Let me take one example. Okay, so here I am taking methylamine or ethylamine, you can take any of this. Ethyl chloride or ethyl halide you take. Ethyl chloride I am taking, and NH3. Now what happens? This nitrogen will attack on this carbon and chlorine comes out, because chlorine is more electronegative, comes out as a chloride ion, creating electron deficiency, so that nitrogen is attacking there. Okay, so what happens here? You are going to get CH3, CH2, NH2. So you got a primary amine, NH2. Okay, so we got a primary amine. So this primary amine is now more reactive than ammonia, because here alkyl group is there now. So it will increase the nucleophilic nature of this NH2 group. So now which is more nucleophile, whether ammonia or primary amine? The product formed here, primary amine, is more reactive than this ammonia. Okay, therefore now what happens during this ammonolysis? Now the product formed will react with the starting material instead of this ammonia. Therefore we are going to get a mixture of amines here. See, primary amine formed now, so this will react with the alkyl halide now. So now what happens, tell me? If it is reacting, now one more R group will be going and attaching on this nitrogen. So it becomes like, for example, here I can take, so it becomes R, N, R again, H here. So we are getting a primary amine. Second, we are going to get a secondary amine. So now secondary amine will react with what? Again it will be more nucleophilic than the primary amine and this ammonia. So now it will be the reacting thing with the alkyl halide, that starting material. So now what happens? You are going to get a tertiary amine here. Okay, now this tertiary amine is more nucleophilic than the secondary, primary and this ammonia. Why they are more reactive? Because three alkyl groups are there now. So it will releases the electron towards the nitrogen and creates more electron density on this nitrogen atom. So if more electron density is present on the nitrogen atom, it will be easily donated to the alkyl halide. Okay. So now what happens, this will readily react with the alkyl halide, that is starting material, and gives you a quaternary salt. The reaction stops once after forming this quaternary salt because there is no other reactive site with the nitrogen. Okay. So we are going to get a quaternary salt like this. Okay. So this is what the thing you need to remember here. Okay. So once again what I am saying, if you take excess quantity of alkyl halide, you are going to get a final product like this, like quaternary ammonium salts are formed as a final products in the reaction. Okay, remember this. Right, let's move forward. So this is about a Hoffman's ammonolysis method. So next one here, Gabriel thalamide synthesis is there now. So it's important ma. It is also a reaction between alkyl halides plus alkyl halides with potassium thalamide. What is this thalamide first of all? Yeah, look at this. This is thalamide. You can treat this with KOH. So now KOH is a base now, so it will abstract an acidic proton first. Okay, during any organic reaction, first of all, if there is any acidic and basic site, reaction, acid base reaction takes place. Okay, so here acidic proton is there and this is a base abstract this acidic proton and resulting to give you a potassium thalamide. Like from here, after abstracting this proton, what is the remaining thing we have? N minus and K plus, because N minus K plus. Why? Because here H is more acidic now, so that is taken by this OH minus, so N minus K plus. So this is called potassium thalamide. What is it? It's a potassium thalamide. So this potassium thalamide and alkyl halide are reacting now. Okay, so now look at this. We know the halide ion is a good leaving group, it goes out. When it is going out, it will be creating a positive charge on the carbon of this alkyl group, right now. So there this nucleophilic nitrogen will attack. Okay, so now we are going to get an alkyl thalamide. Like this. Okay, right. So after forming this, what happens is you just hydrolyze this. What we are doing? Hydrolyzing it. So when you are doing hydrolysis, you just need to break it like this. Okay, because H plus, like out of this OH and H plus now, OH this side, H plus this side. Why this side? Because nitrogen lone pairs abstract this proton. Okay, so here also H this side, OH this side. So what will be the final product we got? We got a primary amine as your final product along with this byproduct. Okay, so here NR2. So this is your primary amine. So it is important point to be remembered that in like in thalamide, Gabriel thalamide reaction, we can prepare primary amines. Which amines can be possible in the Gabriel thalamide synthesis? Only primary amines we can able to synthesis. Okay, it is best method for preparation of primary amines. We cannot able to prepare tertiary or secondary amines from Gabriel thalamide synthesis. Okay, so this is what you need to remember here. And one more thing, which are the following? See, what is the mechanism involved here? If you observe, what is the mechanism involved? See, if I say this is a ethyl chloride or ethyl bromide. Now what happens? This bromide ion goes out, creating a positive charge here, partial positive charge right now, because this bond polarity is towards the bromine side. So now a nucleophile is attacking on this electrophilic carbon and this bromide ion going out as a leaving group. So one nucleophile is substituted by another nucleophile. So it's a nucleophilic substitution reaction. In nucleophilic substitution reaction, what happens? One nucleophile goes out, another comes in right now. So now here the important point to be remembered that the limitations whatever you have studied in SN1 and SN2 valid here. Okay, so what are the limitations we have studied? Alkyl halides will involve, but aryl halides, will they involve in the nucleophilic substitution? This halobenzene like chlorobenzenes, they won't involve in nucleophilic substitution, no? So this species will not undergo Gabriel thalamide synthesis. It means we cannot able to prepare aniline, we cannot able to prepare this aniline in Gabriel thalamide synthesis, because this chlorobenzene is not involving now, because this chloride ion won't comes out, the nucleophilic substitution does not takes place at this position. Okay, so aryl halides, vinyl halides does not participate in substitution reaction, nucleophilic substitution, no? So that's why these things are not participating here. Respective products like aniline cannot be prepared here. Okay, I hope the discussion is clear. Okay, this is an important factor, and you know there is a question asked on this previously. Primary amines can be prepared, that is true. And the second statement, can we prepare, can we do this reaction with the halobenzene, I can say chlorobenzene. Well, which are the following substrate will involve? Okay, will this substrate involve in Gabriel thalamide? No. Will this involve? No. Why? Because the nucleophilic substitution does not take place at this sp2 carbon in the given substrates. Okay, that is what you need to remember. Okay, then next, right. The next method is from alcohols. Simple, you just take alcohol and treat this with ammonia. What happens? From ammonia you have NH3 now, so just remove this OH and this H. So what happens? You are going to get a RNH2 type of product. That's it. This is what you are going to do in these alcohols. Okay, right. Next from carboxylic acids and the derivatives, we have this many reactions. All of them are important. So first of all, remember, what do we mean by derivative of carboxylic acid? See, if I take an amide, or I can take cyanides like alkyl nitriles, or I can say amides. If you take these things, or you can take esters, or you can take halides, acid halides, any of this compound, if you hydrolyze it, what is the product formed? The product formed here will be carboxylic acid. So what is the product formed? Carboxylic acid. So that's why all these are considered to be derivatives of carboxylic acid. What they are? They are derivatives of carboxylic acid. That's why carboxylic acids and their derivatives can convert it into amines. Okay, that is what we are going to study now. Okay, so one by one we will be looking. First one here, first and important one is Hoffman's degradation. So this is one of the very important reaction, I will tell you. Okay, first one is Hoffman's degradation. So you just take Hoffman's Hoffman's degradation is also considered to be Hoffman's bromamide degradation. Okay, so it means we are taking amides. What we are taking? Amides. Okay, in Hoffman's degradation method, what involves? Amides. So these amides with bromine or any halogen like chlorine, bromine or iodine. Okay, so in basic medium, NaOH, bromine plus NaOH. So this combination can also be given in this way, NaOBr, NaOBr. So any of this combination is fine here. So now what happens is, whatever the CO group you are seeing here, like carbonyl group you are seeing here, that will be removed. So if it is removed, what is the final product you are going to get? RNH2 is a final product. Primary amine is your final product formed during this reaction. Okay, right. Hope the discussion is clear. For example, I am saying you here, what will be the product formed? Tell me. CH2, CO, NH2 plus NaOBr. Tell me what is the product formed? Yes. So just remove this carbon, like carbonyl group, you are going to get a benzyl amine. That's it. This is what the product formed. See how many carbons are there here. See this phenyl ring and one carbon and next carbon. So almost 7-8 carbons are there. But in the product side, one carbon is less. If there is n carbons in the starting material, the product formed will be having n-1 number of carbons. Okay. See here n carbons, there is n-1. It means here 8 carbons, there is only 7 carbons are there. So this is what the conversion you need to remember. Okay, right. Right, please remember this. The next one is, I will be explaining next one. Yeah. Yeah, so up to now, up to here we have discussed Hoffman's bromide degradation. No? So this remaining two reactions are also like brothers of Hoffman bromide degradation. Okay, I will tell you why I am saying brothers. So in Schmidt reaction, these are three important named reaction. The product formed here and mechanism involved here is the same in these first three reactions, Schmidt, Cartesius and Hoffman bromide degradation. In all these reactions, the intermediate formed is isocyanate, alkyl isocyanate. What is the intermediate involved? Alkyl isocyanate. Okay, right. So now I will tell you, just listen here. Carboxylic acid you take. Okay, this carboxylic acid, upon treating with hydrozoic acid, that is N3H hydrozoic acid, okay, you are going to get RNH2 type of product, that's it. Okay, mechanism I am not explaining, just remember this reaction. Okay, I think I have made some separate sessions for mechanism and all for this Hoffman bromide degradation previously. If you are interested, you can watch it, but this discussion is enough here. Okay, so here also this CO group is eliminated and you are going to get RNH2. One carbon is less in the final product side. Okay, right. So this is clear now. And the next one here, when it comes to Cartesius, you just take this kind of molecule CON3. Okay, so these will be giving you RNH2. These are the transformations you are going to see in first three reactions. In all of them, what is the product, final product formed? Primary amines will be the final product formed in all of these reactions, right? Yeah. So anyone in the comment box having any confusion, please let me know. I am looking into the comment box, please tell me. Yeah. No one? Right. So now what I am saying? Primary amines will be formed in Hoffman bromide degradation, Cartesius and Schmidt reaction. So here reactions are taking place in acidic medium. Okay, like acidic sulfuric acid, like that it will be considered. Okay, right. So what is the intermediate involved here? Alkyl isocyanate. Okay, then next here hydrolysis of amides means you take RCONH2. What is this? Amides you take and add water. What happens? See here, water molecule acts as a nucleophile, attacks on this carbonyl group carbon. What happens? Like NH2 comes along with the hydrogen as a ammonia gas, so that you are going to get RCOOH. Carboxylic acid is your final carboxylic acid is formed, right? Yeah. So carboxylic acid, hydrolysis of amides gives you carboxylic acids along with the ammonia gas here. What is the product formed? Ammonia gas is formed. So this is amide, but there are N-alkyl amides will be there. Yes, take RCONHR and hydrolyze this. Now tell me what happens here, right? So you just have seen that this bond is getting broken out right now in the previous case. So here also if you break this, what happens? RCOOH, carboxylic acid is fine, and what about this? So it will be NH2R. This is your final product. So we got amine as a product, right? Yeah. So if it is N-alkyl amide, you are going to get primary amine as a product. If it's N dialkyl amide, what will the product formed? See. Yes. If you hydrolyze this, you are going to get a secondary amine like NRRH. So secondary amine is a product when you are taking N dialkyl amide. We are going to get secondary amine along with the carboxylic acid as a side product. Okay, so this is carboxylic acid and this is our major product. Okay, so these are the reactions that we need to know. And the next one here, the fifth reaction given here is decarboxylation of amino acid. So alpha amino acid, you just take alpha amino acids like alanine, valine, leucine, like that you consider. So I am saying R, CH, COOH and NH2. So this is a generalized alpha amino acid generalized formula, right? So now what I am doing is I am treating this with a soda lime, that is CaOH plus CaO, soda lime. Okay, I am heating this. Now what happens? This carboxylic acid is removed, like CO2 is removed. That is what decarboxylation we are saying. Okay, so now what is the product formed? RCH, this is NH2 and this H. So it is CH2 and gives you NH2 here. So primary amine is your final answer here. Okay, so this is what the product formed here. So by decarboxylation of amino acids give you amines. Okay, gives you amines. I hope the discussion is clear. From all these starting materials we have prepared this many ways to get our amines. Okay, so from these 5 starting materials we have got all the routes to prepare amines, right? Right. So now till now we have completed from alkyl halides, and the next we have completed from alcohols, and this is from carboxylic acids as well as derivatives of carboxylic acids also discussed, right? Let's move forward with the next preparation method. Yeah, so that is preparation from this thing, azides, cyanides, this thing, let's see. Yeah, let me check everything is clear in the voice, audio, video. Number of carbons. Yes. Okay. See here, in carbons there is. Yeah, the next one is preparation from alkyl cyanides. Okay, let us say cyanides, first of all, if you take cyanides, upon reduction using a reducing agent like lithium aluminum hydride, if you take, what happens? Complete reduction takes place that converts this carbon as a methylene group like R, CH2, and nitrogen will be converted into NH2 group. So you are going to get a primary amine from cyanides. What if I take alkyl isocyanides like R, N, C? So now what happens? Same reduction if we do, we are going to get secondary amines like R, N, CH3, H. So it means you need to remember that whenever you are reducing or reduction of isocyanates, definitely one side, one terminal, there is a methyl group attached. Okay, secondary amine is produced. Okay, so cyanides over, alkyl cyanides over. Okay, and even from nitro compounds also we can prepare this. From where? From nitro compounds also we can prepare amines. From nitro compounds by treating that with SnHCl, like RNO2 is there, means RNO2 is there. So just treat this with SnHCl. So what is the product form? RNH2 will be the final product form. So that's it. Okay, right. Okay, so here there is some selective reduction method, I will tell you. So when there is aromatic nitrobenzene like 1,3 dinitrobenzene is there, so just treat this with ammonium sulfide NH4S. So this will selectively reduces one of this nitro group to NH2 group. This is a previously JEE advanced question, I think so. Okay, so in a multi-step reaction, this is the step, one of the step involved. NH4SH. Okay, yeah. So you can take this as NH4 SH or SH like this. Okay, that's it. This is selective reduction of one nitro group to NH2 group. Okay, remember this is an important step now. Okay, right, let's move forward. Yeah, so what are their physical states? The lower aliphatic amines are there, no, lower, like methylamine, ethylamine. So these lower aliphatic amines are gaseous. So with a fishy smell, they are gaseous with a fishy smell. So primary amines with 3 or more than 3 carbons are liquid. So from propylamine are more like carbons, like amines having 3 or more than 3 are liquid, and higher are solid. So higher amines are solids. So aniline and their other aryl derivatives, aryl amines are usually colorless but gets colored on storage due to atmospheric oxidation. So that aniline and other aromatic aryl amines will get oxidized when it exposed to air. Okay, that's it. So the physical properties, if you see, boiling point. So here boiling point, here what happens is, see, you just write the structure of primary amine, or let us say CH2, NH2 I am writing. So this is a primary amine we know. If you write secondary amine with the same molecular formula, it can be RNH R, like this. So if you observe these two structures itself, you can able to get that nitrogen atom having 3 hydrogens this side and lone pairs this side. So it means it can almost form 3 hydrogen bonds. How many hydrogen bonds it can form? It can make 3 hydrogen bonds. 2 using directly with this nitrogen, and 1 more using this lone pair electrons with the other solvent molecule or other polar molecule like water. Okay, so maximum number of hydrogen bonds possible in primary amines are 3, but when it comes to secondary amine, so it can make only maximum of 2. One is using lone pair, another one is by hydrogen. But it comes to tertiary, it can make maximum of 1. Why maximum of 1? Because it have no acidic hydrogen or directly attached hydrogen, because all of them are alkyl groups with one lone pair. So this lone pair only can be used for making a hydrogen bond with the other polar molecule. But due to the presence of these hydrophobic groups here in the first tertiary and secondary, the hydrogen bond strength is relatively weaker here, right, due to these hydrophobic groups, right. So due to that reason, what happens that hydrogen bonding strength is less, and therefore that gases can be easily converted into that compounds can be easily converted into gaseous state. It means boiling point will be highest for primary, then next for secondary, and least for tertiary, okay, for an isomeric compound. So let's see here we have taken isomers, almost see 73 means they are isomers to each other, right. Say have same molecular formula, but this is primary, secondary and tertiary we have considered. So now look at this, molar masses are same for isomers, structural isomers. Now primary, secondary, tertiary amines isomers can be considered to be functional group isomers. What they are? They are functional group isomers. This is important point more. What they are? Primary, secondary, tertiary amines are structural isomer. Particularly if I want to say, they are functional group isomers. Remember this. Now if you see, primary amine having highest boiling point, as we go from primary to tertiary, boiling point is reduced. Why? Because primary amine have hydrogen bonding, two primary amines, between them hydrogen bonding is there, so strong interaction between them, so more amount of heat or temperature is required to break that hydrogen bonds and make the conversion of that liquid to gas, right now. So highest boiling point for primary, then followed by secondary, and least is for tertiary. Okay, so this is what you need to get from this observation. Okay, hope the discussion is clear. Right, let's move forward. Yeah, so basic character of amines, this is one of the important factor, and we can expect a direct question from here. Okay, first of all, let's discuss about alkyl amines. What I am saying, this is about alkyl amines. Alkyl amines. So alkyl amines, if we consider, so RNH2 dialkyl, that is RRNH, and trialkyl RNRR, like this, trialkyl. So this is primary, secondary and a tertiary. This is fine up to here. The next what I am doing is, I am taking one example. If R is methyl, what happens? If R is methyl, so the basic nature order, when R is a methyl group, the basic nature order will be tertiary, more basic, then tertiary, secondary is more basic, then next tertiary, and least is primary. Not sorry. 2, 1, 3. So when this scenario will be observed, when alkyl group is methyl group, this will be the basic nature order. Basic nature order. Okay. So remember, if other than alkyl group, other than methyl is there, if alkyl group R is other than methyl, okay, other than methyl CH3, then what happens here is the order becomes 2, 3, 1. Okay. So this is a basic nature. So why this order is varying like this? See, actually what do we mean by basic nature? First of all, remember this thing. Next, learn the concept here, what I am saying here. See, basic nature means it is the ability of nitrogen atom like amines to get protonated, like to accept this proton or to donate this lone pair electrons to a proton, right? Now that is what basic nature means. Now here in tertiary, if you see, there are 3 alkyl groups. So more electron releasing groups, more is the electron density and the nitrogen, easily they can donate to the proton, right now. So it means what should be the basic one? Most basic one should be tertiary, right now, because 3 alkyl groups, more is the releasing group nature. So easier to donate electrons to the H plus, and easily they will accept the proton, right now. It means tertiary should be more basic, and here 2 alkyl group means next followed by secondary, and least should be primary. This should be the actual scenario that we may think, right now, because more alkyl groups, more is the releasing nature, more is the basic nature, right now. Yes, this is true. It is perfectly true, but this is true in gas phase only. So when it is true, it is accepted only in gas phase. Okay, but here which I have given, this is in aqueous medium, where it is in aqueous medium. So in aqueous medium, what happens? We need to not only checking these alkyl groups, but we also need to check the stability of conjugate base formed. Okay, why we need to check for the conjugate base formed? Because see, we know the organic acids are weak acids, we are saying, na? Similarly, organic bases are also weak bases. Okay, it means organic compounds are weak electrolytes. I mean, organic acids are weak acids, organic bases are weak bases. So this can be a weak electrolytes. Okay, right. So now in case of weak electrolytes, we can have a equilibrium reaction. It means equilibrium step. Okay, so for example, R NH2 is there, ma. Now what happens when I treat this with water? We are going to get something like this: R NH3 positive charge plus OH minus. Okay, this is what we are seeing. Now what do we mean by basic nature? Basic nature means it should have more OH minus ion concentration, or it should easily accept this H plus. That is what the basic nature means, right? So now in order to make it more basic nature, it means concentration of OH minus should be more, means now what happens if this equilibrium moving forward means we will get more OH minus. So in order to accept this, whatever the species formed, in order to convert this or in order to move this equilibrium to forward, means the like whatever the product formed should be stable. If this product is stable, then equilibrium moves forward. It means it becomes more basic, right now. So more forward it is moving, more is the basic nature for that, because more OH minus ions are formed. So I hope you got the concept, right? So now we need to check for the stability of conjugate acid formed. See, if it is a base, after accepting proton, the species formed should be called as conjugate acid. See, I am not giving you just a concept here, I mean normal discussion. I am trying to provide the concept, what is the concept involved there. So you need to check for the conjugate base. If the conjugate base is more stable, then equilibrium moves forward, then I can say more OH minus ion formed, that means it is more basic, right? So this is how you need to think of it. Okay, right. So now what I am doing is, if this conjugate base is more stable, I am saying it is more acid, like equilibrium shift forward, that is more basic I am saying. So now the stability of conjugate acid formed here now depends on this alkyl groups, that is electron releasing groups. Stability depends on what are the things? One is Stability depends on electron releasing group and also solvent effect, that is nothing but hydrogen bonding. Okay, these are the two factors to be considered. So more number of hydrogen bonds are formed when it is a primary amine, and more number of alkyl groups are there when it is a secondary tertiary amine. Now considering both effect, we are getting this kind of order in the aqueous medium, but in gas phase it depends only on alkyl group, releasing groups are more is the basic nature of that amine. So gas phase is like this, in aqueous medium is like this. Okay, hope the discussion is clear. What are the important points to be remembered? The factors here deciding the basic nature is, one is solvent effect and electron releasing groups. Okay, that makes that decides the stability of conjugate acid formed. That makes, if more conjugate acid is more stable, that will be respective base should be more basic. That's it. Okay, right. So right, let's solve some more questions here. When it comes to a aromatic amine and an aliphatic amine like methylamine, so which is more basic, they will ask. See, out of these two, aromatic and aliphatic, always aliphatic. Why aliphatic? See, in aromatic amine, the lone pairs are not free to accept this. They are already in conjugation with the ring pi electron. See, lone pairs, sigma bond, pi bond. So they are already in conjugation. It means they are not freely sitting here because they are in conjugation with the ring electron. So they are less available to accept the proton. But here methylamine, lone pair electrons are not in any of the conjugation. They are freely available here. They are just sitting on the nitrogen. So easily accept this proton. So it means who is donating the lone pair electrons easily? The nitrogen of this aliphatic amine. So that's why aliphatic amines are more basic than aromatic amines. Okay, remember this line. Right, let's move forward. Yeah. Guys, if the discussion is clear, please hit on the like button. So now I will be adding few more examples of aromatic amines. See, so ABC. So before going to that, you can also give me answer for this. Yes, out of these two compounds, which is more basic? Which is more basic out of these two compounds? So how can you answer this? How can you answer this? See, what I told you, if a compound accepting H plus ion easily, then we can say it is more basic. Now see, in order to accept this H plus ion, the lone pair electron should be freely given to the H plus ion. But what type of groups here they have? Nitro group, here also nitro group. This is electron withdrawing groups. Now, if electron withdrawing group is very close to that nitrogen, there will be more inductive effect. So more minus I effect is there, that nitro group will drag the electrons from the nitrogen. It means it is not freely given here when it is close. See how close it is, just one carbon between these two nitrogen of amine. Right now, but here 1, 2, 3, so 3 carbons are in between, so it is far, it is close. If it is close, its basic nature is less because that electron withdrawing group drags the electrons towards itself. So now I am making a statement, the electron withdrawing group containing amines are less basic, amines are less basic, okay. So now other ways I can say electron withdrawing groups decreases basic nature of amines, whereas electron releasing groups increases basic nature of amines. If there is releasing groups, basic nature is more, withdrawing groups, basic nature is less, that's it. So P is more basic here, so second one is relatively more because nitro group is relatively far from this nitrogen and like NH2 group, so it is relatively more basic, okay. Hope the discussion is clear. Right, now tell me here the same concept you can use here. So now tell me what type of groups here along with the aromatic rings. Here we have a electron withdrawing group, here alkyl group is electron releasing group. Now just now I told you releasing groups increases the basic nature, so because they will releases electrons into the system, in that case nitrogen is easily donating their lone pairs to the H plus, accepting H plus easily. So C is more basic. Between A and B, withdrawing group means least basic, and in between A, that's it, cap. So this will be your answer for the question. Hope the discussion is again clear. Is there any confusion here? No, right? Right, let's move forward. Right, so till basic nature you got complete idea, right? So I will give you few questions, try to answer me them in the chat box, okay. We will discuss about them in the next class. Just will provide some questions here, just tell me what will be your answers. So basic nature order. Basic nature for A, B, C. Okay, this is first one. The next, second question A, B. Okay, so please mention question number and provide your answer based on your understanding for these two questions. Okay, I hope whatever the session you have followed till now is really helpful for you and you have followed, I hope you followed this session perfectly with full of attention. Yes, if you have any queries or any confusions, please mention in the chat box. I will definitely address them in the upcoming session. So thank you for watching. Stay connected with our NEET World YouTube channel. Thank you.